Alrighty then. Section 2.5, proving statements about segments and angles. So, first thing, a proof is a logical argument that uses deductive reasoning to show that a statement is true. These proofs tend to be difficult. They tend to be not easy. You usually need to go over it more than once just to understand what it is. So for two-column proofs, it's a two-column proof. I wonder why it's called a two-column proof. We went over this before because there's two columns. This first column is the statement. These are statements, and this column here are the reasons that support those statements. Okay. You will need to refer to these, here we go, these properties of reflexive property, symmetric property, and transitive property. And there's some more down here. The only difference between these two is this one is regarding segments, this one's regarding angles. Really, there's not a big difference between these two. This one's about segments, that one's about angles. It's still reflexive property. They still have symmetric in both of these, and they still have transitive property in both of these. Okay. Now, I would suggest that when you do this stuff, you look at these example two-column proofs. So in this example two-column proof right here, you may want to look at that and go, oh, there's an example. I need to look at some of these examples. Okay, there's some more examples in the bottom of 101 and also on page 102. So right up here in the top of page 102. Well, let's dive right into this and let me show you some of this stuff right here. Number one, how is a theorem different from a postulate? Well, a postulate is a rule that it's accepted to be true without a proof. A theorem, it can be, in order to be true, you need to prove it. Postulate is accepted as being true without a proof. A theorem, it needs to be proven. Okay, that's the difference. A postulate, 1 + 1 is 2. Yeah, most people are going to go, yeah, I don't need to prove that. 1 + 1 is 2. Sure, I definitely accept that. Maybe not for a 3-year-old, but for you in high school, yeah, 1 + 1 = 2. That's pretty straightforward. Okay. Complete the sentence. In a two-column proof, each blank is on the left and each is on the right. I wonder what we put right there. If only they had something somewhere in here that gave us an example of what we had to do here. In each two-column proof, let's say there's one column here on the left and a second column here on the right. And in a two-column, each blank thing on the left and each something on the right. I wonder what word goes with there. I think they end with a letter S. I think both these end with the letter S. I wonder what those would be. I'll let you figure that out. Okay. Question number 3. Copy and complete the proof. So given we have this stuff, we're going to have to copy this diagram and copy the two-column proof. Okay. So I did this ahead of time so I can actually have it written down so it wouldn't take as long. So here we go. Let me write it. Actually, I'm going to do this on flat sheet so it makes more sense. Right down here. There we go. And again, make sure in the upper right-hand corner, when for your assignment, make sure you put your name, date, period, teacher, and your assignment goes over here. Name, date, period, teacher, and your assignment goes right there. For question number 3, here's my diagram. We have to prove PQ = RS. So that's the first thing you do. The first thing you need to do, according to the problem says given this. So what goes here? It's given. It's given, silly. And it says prove PR = QS. So on your statements, once you get down to where it says PR = QS, once you get down to that point, don't go any further. You're done for your statements. You just have to fill out the reasons why. Okay. So PQ = RS, that part's given. Then it says PQ plus QR = RS plus QR. Wait a minute. What? So basically we're saying that if we hide this stuff right here, on the left side we have PQ, just like we have above. On the right side, we have RS, just like we have above. So the only thing we're doing on both sides is we're adding QR? That's the addition property of equality. We're adding QR, add QR to this side, add QR to that side. Okay. Next, this one is a segment addition postulate. This is postulate 1.2. It's on page 14. The segment addition postulate. It's on page 14. It's on page 14. That's on page 14. All right, there we go. It's on page 14. Okay. Segment addition postulate. It's a postulate, so it shouldn't need to be proven. You just look at it when you go back on page 14 and you go, oh, yeah, that makes sense. Okay. Well, what the heck do you put there? Well, in the meantime, I'm going to skip down because I see these two have the same exact reason why. And so that means if these two have the same reason, these two are going to be similar. They're going to be somewhat similar. RS plus QR equals QS. So from R to S, from RS, if you take that distance plus QR, from R to S, that distance plus QR is going to equal from Q to S. Wait, that's all it says? Yeah, that's the segment addition postulate. You take this stuff, QR plus RS equals from Q to S. Hey, and the same thing you're going to have above. It'd be nicer if they had these switched in order. So it said QR plus RS. So over here, PQ plus QR equals PR. So that's what I'm going to put right here. This just takes a while before I'd be able to get a hang of this stuff. PQ plus QR equals P to R. Now where did I get that? Another reason that I'm looking at that, PQ plus QR, it's right here. Where'd they get RS plus QR? Why don't they write QR plus RS? Because that right there is exactly right here. And we're going to use this stuff in a bit, and we're going to use this stuff in a bit. Okay? Well, PQ plus QR equals this, and RS plus QR equals that. So if this stuff is equal to that stuff, remember, right here it says this equals this, and that stuff is right there, and 1, 2, that stuff is right there. If those are equal to each other, if that's equal to this, according to this, then what do we know about these two? PR and QS. What do we know about PR? There's only something that was written down. What would it be? PR equals QS. Oh, that's the, if this equals that and that equals that, that's the transitive property. Oops, sorry. Transitive property of equality. It's equal sign, so you put an equal sign. There you go. Done. Okay. Write your two-column proof. Make sure you write the diagram as well. Okay. When we get to question number 5. Question number 5. Here's number 5. In exercise 5-10, name the property that the statement illustrates. So if PQ is congruent to ST, and if ST is congruent to UV, then PQ is congruent to UV. What would we do? Here's my, that's not it. I had my piece of papers. Hold on, 2 little pieces of paper. There they are, right there. So I took these. So if PQ is congruent to ST, and if ST is congruent to UV, then some other stuff. Well, I'm going to take these two. Can I take these two and do this? Is this and this, are they the exact same thing? Nope. okay, what if we do this and write it this way? So I put this underneath like that. Are these the exact same thing? This and this, are they the exact same thing? Yes, they are. So if you have this is congruent to this, and if this is congruent to this, we're saying, then this is congruent to this. Okay, and that's what that states right there. Segment PQ is congruent to UV. What's the property that says that? What's the thing that goes choo-choo? Train? Yeah, transitive property. Yeah, it's a stretch when I say train, transitive, but I got nothing. Okay, transitive. That's the transitive property. Okay, question 6. Angle F is congruent to angle F. Angle F is congruent to angle F. So if you go back and look at these statements here, there it is right there. Properties of congruence for segments and properties of congruence for angles. These two are angles, so it's going to be referring to angles, angle F and angle F. Okay, so that is going to be reflexive property of angles. Reflexive property of angle congruence. It's a reflexive property. Just put reflexive property. That's fine. Question 7. If angle G is congruent to angle H, then angle H is congruent to angle G. On this stuff, you don't need to worry about, oh, look, this is the exact same thing as that. So therefore, if angle G is congruent to angle H, and angle H is congruent to angle G, then, hey, that angle is congruent to that. We already know they're congruent to each other. This right here, all you're doing is you're taking the stuff and you're switching the order. So you take this, the converse, and you get the other thing. Sorry, you get the other one. For question 7, that's symmetric property for question 7. That's symmetric property. Okay. Blink. I'll let you do 8, 9, and 10. Question 13. Question 13. Copy this stuff and copy the diagram, and we have to make a 2-column proof. 2 columns. Why do they call it 2 columns? Because there's 2 columns in the proof. So here's the diagram. I'm going to put this away and write this. There we go. So right there. So draw the diagram. So these are going to be straight lines, straight line, straight line, straight line. Okay, they're straight lines. Okay. What do you start with? What's the stuff that's given to us? Angle GFH is congruent to angle GHF. Not the same thing. There's the same 3 letters, but in a different order. This one means GFH, from G to F to H, G to F to H. That angle is congruent to this one. Start at G, go to H, go to F. G to H to F. These are congruent here. Put something underneath that so it writes a little better for me. So we get up, there we go. That's a little smoother arc. Those angles are congruent because it's given to us. That's given to us. Okay. Then I think I'll be able to do this stuff ahead of time and like fold a piece of paper. Okay. Then I'm going to write angle GFH and angle EFG. So GFH, that angle right there, and angle EFG from E to F to G. So this angle plus that angle form a linear pair. Okay, and that's given in the diagram. That's a straight line. So yes, we can make a conclusion that these are a linear pair. This angle plus this angle equals 180 degrees, or they form a linear pair. Okay, if they form a linear pair, wait, what's the definition of a linear pair? It means they have to be adjacent and they have to be supplementary. If they're a linear pair, the angles have to be adjacent and supplementary. Well, if that's the case, then angle GFH and angle EFG are supplementary. Why? Because that's the definition of a linear pair. Definition of a linear pair. Okay. Next, if they're supplementary, that means they equal 180. Okay. This angle, if this angle and this angle are supplementary, that means this angle plus that angle equals 180. What's the definition of supplementary angles? Two angles whose sum is 180 degrees. Two angles whose sum is 180 degrees. So that right there is the definition of supplementary angles. Okay. How do we know when we're done with this proof, by the way? We start with this and we end with this proof. So you always start with the given and you always end with the proof. Now we're talking about on the statements. So our first statement should be this for this column, and our last statement should be that. That's how you know when you're going to be done. You start and end at those. Okay, so we have this. Okay, then we're going to go down to here. Wait a minute, from here to here, aren't those statements the same thing? 180, exact same thing, exact same thing, exact same thing, both pluses, exact, sneaky, sneaky. These are not the exact same thing. This is GFH, angle GFH, from G to F to H, it's that one. This one is angle GHF, from G to H to F, it's this one. So what says we can change it from this to that? How can we do that? Oh, if only there's something here somewhere that says we can do that somewhere on here. Where would that be? Is there something on here that says we can do that? I wonder if somewhere says we can do that. Right there. These angles are congruent to each other. And that was given to us. So instead of writing GFH, I substituted GHF right there. That's a substitution property. Okay. It's a substitution property of equality. Okay. Well, what do we have to prove? We have to prove that they are supplementary. Well, if these two angles add up to 180, two angles whose sum is 180, isn't that the definition of supplementary angles? Yeah, these angles are supplementary. Right here. Angle EFG and angle GHF are supplementary. That's going to be our last statement. Here's our last statement. We just have to prove it. What's the definition of supplementary angles? Hey, they have to add up two angles whose sum is 180. We've already shown that they do that. Definition of supplementary angles. We're done. This stuff is not easy. You can follow someone else do this, and when they do it and you go, oh, okay, I kind of understand someone else doing it, but for me to do it myself, whoa, that's hard. You're right, this stuff is not easy, especially at the beginning. This stuff is not easy at the beginning. So beware of that. It's not going to come really naturally to you. If it does, fantastic. But I doubt it's going to come really easy to people. Okay? Good luck, guys. Bye.